In example 1, what we want to look at is how sets are equivalent to propositional statements and Boolean logic. So let's start by saying we have a few sets, P, Q, and R. Okay? And let's create a few rules, and then we're going to forget about those rules, right? Let's say that we have a rule P. And rule P means that X is a member of the set P. We have rule Q, which means that X is a member of the set Q. And then we have rule R, which means that X is a member of the set R. All right? So those are our rules, and we're going to immediately forget about them and start moving on to other things, but keep that in the back of your mind. Now, if you remember our rules from set theory about the set distribution rule, it looks very similar to other distribution rules, and what we're going to do is prove that it's the same as our Boolean logic and Boolean function and propositional logic distribution rule. All right? That rule was, if you have the set P intersectioned with sets Q union set R, that is the same as P intersection Q, that set unioned with P intersection R. Right? That's the distribution rule from set theory. If we go back to our rule before, right? According to those rules, X will be a member of P intersection Q union R if and only if X is a member of P intersection Q union P intersection R, which makes sense because that's what our distribution rule says, right? Now, knowing that, what does X exist inside the set P intersection Q union R mean? Well, it means that X is inside set P, right? And X is a member of Q unioned with R, right? What does X is a member of Q union with R mean? It means that X is a member of Q, or X is a member of, I'm running out of space here, but you get the idea, R, right? And remember those rules we did a little while ago? Well, according to those rules, what this really means, this is the equivalent to this. This is the equivalent to that. This is the equivalent to that, which means lowercase p and q or r. Therefore, the rules for set theory are exactly the same as the rules for Boolean functions and the rules for propositional logic. They're all different ways of saying the same thing. Okay, just to make sure that it's perfectly clear, let's go ahead and do that again with the other example. Okay, remember the other side of our set's distributive law, right? X exists inside P intersection Q union with P intersection R. And again, what does that mean? That means that X is inside P intersection Q, which means that X is a member of P, or X is a member of Q. What does this mean? That means that, ooh, I forgot that there. X is a member of P intersection R, which means that X is a member of P, or X, you get the idea, is a member of R. And one of these things is, both of these things need to be true, so that's joined by an and, which means P or Q and P or R, which is the other half of our distributive rule, right? So the distributive rule for sets is exactly the same as the distributive rule for Boolean functions. All right, now, why is this important? Because this means that we can use, well, actually, there's two things. One, we can use sets and subsets to illustrate Boolean functions, and sometimes it's much easier to grasp. But the more important thing is we can use Venn diagrams to prove propositional statements, right? And Venn diagrams are usually much easier to kind of see what's happening than a traditional propositional proof, right? So that's example one. If you have any questions, ask in the forum below.